All right, so in this video, we're going to go over our first day of circle theorems. Just looking at the triangles. Today, we're going to talk about tangents and circles, and we'll talk about what a tangent is and all that good stuff. But before we do that, we need to make sure that you feel comfortable with Pythagorean theorem. So, the first one we're going to look at here, remember this only applies if it is a right triangle. If it is not a right triangle, none of this works. So here I have my two legs. So this is going to be 8 squared plus 15 squared equals c squared, c being the hypotenuse. 8 squared plus 15 squared. I would just put that right into my calculator as is, and that gets me 289. And then if I want just C, I'm going to take the square root of both sides, and that tells me that, my C value would be 17. Because the square root of 289 is 17. And this is, if you have something like this where you have whole numbers for both legs and the hypotenuse, that's called a Pythagorean triple. Just FYI. All right, so for the next one here, I'm missing a leg. So this is going to be 9 squared plus x squared equals 10 squared. And because I'm going to try to do as much as I can in my calculator without having to do a whole bunch of extra steps, I'm going to subtract 9 squared here. So I'll have x squared equals 10 squared minus 9 squared. And I think I ran out of room. Oh, I have a little bit. So 10 squared minus 9 squared is 19. So x squared is 19. Getting just x, I'm going to do the square root. So x would be, rounding, 4.36. Now, if you didn't want to do this and subtract 9 squared, you could do 81 here and 100 here, and then subtract 100 minus 81. Either way, slice or dice it, you're going to get 19. Now, with this last one, I have a right triangle here on the right and on the left. So what I'm going to do first is I'm going to use this triangle here. Let me get a different color. I'm going to do this triangle first. And I'm going to find this vertical leg. That's better now that you can actually see it. And then I'm going to do the pink triangle to find the hypotenuse. So I'm going to label this leg B, and I'm going to label this C because this is the hypotenuse of this triangle over here. All right, so starting on the blue side, I have 5 squared, because that's the hypotenuse, being equal to 3 squared plus b squared. Again, I'm going to try to do as much in my calculator as at one time as possible. So I'm going to subtract 3 squared. So I have b squared being equal to 5 squared minus 3 squared, which gives me b squared being equal to 16. And taking the square root tells me that b is 4. So now I know this vertical space here, that length is 4. Then I can move over onto the left triangle that I've labeled the pink triangle. And I have 7 squared plus, now I know B is 4. So 7 squared plus 4 squared gives me 65. So this is not going to be a pretty number. Oh, brain fart. I have to take the square root. So C, oh, hold on. My calculator's not working with me. And the square root of 65 is 8.06. So that's one of my answers. And there is my other answer. All right. So now we're going to start moving on to some vocabulary with our circles. Now, in your notes, I know it's blank. I have mine already filled out. So we're just going to kind of talk about these step by step. And I'm going to zoom out here a little bit so you can see everything at once. All right, so using this picture here, the radii, or a radius, depending on if you have multiple or just one, we know that that's from the center to a point on the outside of the circle. It can be any point on the outside of the circle. The radius is always going to be the same. And that's half of the diameter, which we remember the diameter is from any point on one side through the center to a point on the other side of the circle. The difference between the diameter and a chord, any chord, is the diameter has to go through the center. A chord does not. A chord is just any 2 points on the edge of the circle getting connected. So that's the difference between those two. The difference between a chord and a secant is that a secant has those arrows on the end because it's a line. It is not a segment. So a chord and a secant are similar. Some people say secant. It's fine. It doesn't matter how you say it. It's like tomato, tomato, whatever. But the difference between a chord and a chord is a segment, a secant is a line. It's going on forever. And then a tangent line, if you see down here, there is one point here on the edge of the circle. And that line comes up against the circle, touches that point and that point alone, and then continues going on in the other direction. It is possible to see a segment here instead of a line. We will experiment with those in a little bit. This does not have to be a line. A secant does have to be a line. And then just as a little reminder, circumference and area and the formulas are there for you. Circumference and perimeter are like the same thing, but circumference is specifically for a circle, perimeter is for any shape. And just to make sure that we remember all of the things with the mathing of circumference and area, we're going to do 2 examples down here at the bottom. If I can get my camera to agree with me. So find the radius of the circle if the area is 72 inches. So I'm going to use this formula here. I know that area is 72 inches, so I'm going to replace 72 with A. And then I'm going to divide by pi, because remember, pi is just a number. And now that we're in our circle unit, we're going to work on being more precise with our calculations and with our statements for these pieces. So I'm going to leave r squared for the moment as 72 divided by pi. Now I know that that looks weird. I get it, but just trust me. Now in order to get r by itself, I'm going to take the square root here. And if you're using your scientific calculator app with Desmos, you can do the square root, put a fraction inside, and then do 72 divided by pi all in one step. So here, our radius would be 4.79. And that unit here is inches. Now we did have to round, so we know that this is a rounded estimate of our radius. It's not exactly perfect, but it's close. So in the second one, we're going to do circumference and area. So I'm starting with circumference. And they want us to find the radius. So instead of using pi d, I'm going to use 2 pi r. And I know that the circumference is 40. And I'm going to divide by 2 pi. Now, you can do this, again, all in one step. So I have our radius being equal to 40 divided by 2 pi. Or if you see that this right here will simplify, 40 divided by 2 is 20. So this is also equal to 20 divided by pi. Now that's not to say if you didn't see that you couldn't just do 40 divided by 2 pi. You would still get the same answer. So 20 divided by pi tells me that our radius is 6.37 inches. So there's part one of our answer. And then for the area, we're doing pi r squared. So I have pi times 6.37 squared, and I can put that in 6.37. Oop, it helps if I actually clear out what I did. Pi times 6.37 squared. So our area is 127.48. I'm going to round up here. So there's that. All right. Now comes the fun part. All right. So in 3 and 4, I want to find area and circumference again. So here, this is a square. All of my sides are equal. So that tells me that this is a right angle here. So in order to find this diameter, I'm going to do 5 squared plus 5 squared equals, and I'm going to use d for diameter. So 5 squared and 5 squared is 50. So our diameter then, let's see, square root of 50 is 7.07. And remember, the diameter is twice the radius, and I need the radius for area and circumference. So the radius is that divided by 2, which would be 3.54. So for circumference, I can actually use 7.07, and I'm just going to do pi times diameter, which gives me 22.21 inches. And then area is pi times our radius squared, which is 39.37 square inches. So I want you to take a second and pause this video and try to do this one without me. Now, keep in mind, I see square root of 3 here, so that's making my brain think of a 30, 60, 90 triangle where I have a square root of 3, and 2a to make your life easier. So pause, try it, and then come back to me. So this is my a value because I see that in front of the square root of 3. Now, if you didn't see that, that's okay. You could do 8 squared plus this whole thing squared equals the diameter squared. Or I could see that I'm doing a 30, 60, 90 triangle. So this would be 2 times a, which is 8, which means my diameter is 16. So our radius in this case also happens to be 8. So our circumference is pi times 16. Oh, my calculator locked. There it is. So here we have 50.27 centimeters. And then for area, I have pi times 8 squared, which gives me 201.06 square centimeters. All right, so that's reviewing everything we know about circles so far. Now comes the fun stuff. Just kidding. It'll be a blast. We'll be fine. So our first one, now we're dealing with tangents. So a line is a tangent to a circle if and only if the line is perpendicular to a radius of its circle at its endpoint on the circle. So what this is telling me is that a line is a tangent to a circle if the radius and that tangent meet at a right angle at that endpoint on the circle. So right here at this point here, A, this would be a right angle. So what I see here, and I'm going to do this in pink, is I see this whole triangle here, pretending I can draw straight lines. No judgment here, please. That is a right triangle. So I can do Pythagorean theorem. Now we have to be careful because X is only this segment from B to C. This here is also a radius, so I know that this is 8. But the hypotenuse is this whole side of the triangle here. So this is x plus 8. So when I do Pythagorean theorem, I'm going to have these two legs. So 8 squared plus 15 squared, and it's going to be equal to the hypotenuse, x plus 8, that whole quantity squared. Now, since we did expanded form yesterday, you might be thinking that we're going to have to do the box and multiply this through, but we don't have to. I can simplify this over here. So 8 squared plus 15 squared gives me 289 being equal to the quantity x plus 8 squared. And guess what? Since I have a quantity squared, I can do the square root of both sides. Square root and square undo each other. So this will be 17 being equal to x plus 8. And that doesn't look so bad, does it? So I'm going to subtract 8 from both sides, which tells me that x is equal to 9. Example number 2 is a little bit different because in this case, now x is the entire hypotenuse. So here's my right angle where the radius and the tangent line meet. So this one is just 15 squared plus 20 squared being equal to x squared. Again, grabbing my calculator, 15 squared plus 20 squared gives me 625. Taking the square root of both sides gives me that my value of x is 25. Now I want you to pause and I want you to try example number 3 without me and use example number 1 as a boost or a starting point to get you through example number 3. When you finish, hit play and come back. So this is also a radius. So this whole thing here would be x plus 5. So I'm going to have 5 squared plus 12 squared is the quantity x plus 5 squared. Putting that into my calculator, I get 169 being equal to x plus 5 squared. I'm going to take the square root of both sides. Square root of that is 13. So this tells me that x has to be 8. All right, last theorem of the day. Tangent segments from a common exterior point are congruent. So, from the point of tangency to the exterior point, they are equal. So here in circle P, here's the point of tangency, and then here is my exterior point. So, guess this lost its label. We're going to label that A. So from A to C is the same as from B to C. This is the shared point. These are the points of tangency. So those two things are congruent. So I know that 40 is equal to 3x plus 4. And then I just have to solve for x. The hardest part about these is making sure that you remember and understand what piece of the puzzle you're trying to use. So in this case, our puzzle pieces is that these two things on the outside are equal. So subtracting 4 gives me that 36 is equal to 3x. Dividing by 3 tells me that x is 12. Now this next example, number 5, is a little bit tricky, and I'm actually going to use 2 different colors on this one because I have 2 different exterior points that I'm looking at. So here I have AB being congruent to BC because this is the shared exterior point here. On the other side of that, CD and ED are going to be congruent because they are sharing this exterior point. So this is going to be 4. So just so B was my shared point, so AB is congruent to BC. So BC is 3. And here, CD is congruent to DE. So CD was 4. Now to find X, well, X was those 2 things put together. So it was 3 plus 4. So X is 7. Now these statements here, you don't have to write those kinds of statements down, but just so that you have that, I wanted you to see it so you were okay. All right, last but not least, OB here is 6. AB is 8, and we have to find EA. So it's labeled with a question mark. I'm going to label that X just because we like variables better. Now, this is a radius, and I have another one from O to E. So this is also 6. So this actually goes back to kind of like what we did before. So I've got 6 squared plus 8 squared being equal to x plus 6 squared. 6 squared and 8 squared added together is 100. And then I'm going to take the square root. So 10 is x plus 6. So here x is 4. Now just to drive this point home a little bit with this exterior point being congruent, here since B and D are on the exterior of the circle and they meet at this common point here, I know that these 2 things are congruent. All right, last but not least, finding some angles. Well, A, B, O. I have a radius that's meeting a point of tangency. So that has to be 90 degrees because they meet at right angles. ODC. So this angle here, I have another radius meeting a tangency line. So this also has to be 90 degrees. If DOB is 120, let me grab another color. So here's 120. We have to find EAB. EAB. Okay. So any 2 angles that meet and create a straight line are supplementary. So these 2 things added together have to make 180 degrees. Well, 180 minus 120 tells me that this is 60. And then here is my right triangle. So these two angles together have to add up to make 90. Well, I'm missing 30 degrees.